So now the last topic in alkene series is something that we call test for saturation. And by saturation and unsaturation, basically this is a test for unsaturation. Yeah, not saturation. We're going to call this test for unsaturation. And what's going to happen in this is basically the first thing that you guys need to know, which you already know, because if you have come all the way till here in the series, then you already know what a saturated and an unsaturated hydrocarbon is. So assuming that, now you know that the saturated hydrocarbon is your alkenes, right? Saturated hydrocarbons are alkenes, saturated, and alkenes are your unsaturated hydrocarbons. But how do we test this out? So if I were to place two molecules in front of you and I'll say this is an alkane and this is an alkene, how would you tell me that which one is saturated? Oh, if I've already told you, then you guys would already know. But if I put two molecules in front of you and then I ask you to tell me which molecule is alkane, which molecule is alkene, you won't know, right? How can we know that? We cannot know that. So to test that, what do? We react it with aqueous bromine. Okay, and aqueous bromine is actually bromine dissolved in water. Simple. So we tested whether it react with aqueous bromine, and once that reaction takes place, so what happens now? This aqueous bromine is, you can say, brownish color, or you can also say reddish color. I think brownish is the right word, is it? Yeah. So now this is a brownish color bromine, and when you react it with alkane, what's gonna happen? When you react this bromine, aqueous bromine, with alkane, nothing happens. So the brownish color of aqueous bromine remains. So what's happening at the first stage? We are reacting alkane with aqueous bromine, and the bromine has a brownish color, and there is no color change. So the color remains same. Okay, so the color remains same. Now, if we were to test for, let's say we were to test for alkene, I'll just scroll down the page a bit. Yeah. If I were to test for alkene, now alkene, once we react with aqueous bromine, which again we said is a brownish color, what's gonna happen? That brownish color is gonna disappear. Yep, it's gonna disappear. It will become colorless. So the color change is from brown color to colorless. And if that happens, then you know that the solution contains an alkene molecule. And that means that this is unsaturation, like the test for, like the molecule is unsaturated. So this is how you differentiate or distinguish between the two things. Okay, I hope that this was easy, pretty easy, and this is asked a lot, right? In exams, this is one of the things, most common thing that is asked. Okay, so this is one thing. Now, if we're to talk about just one more small thing, which is basically making of margarine. Sorry, making of margarine. Now, this margarine is, as you guess, is the same thing as you eat as blue band. This is the same. Yeah, this is the same thing, and you basically make it from vegetable oils. So you have a vegetable oil molecule, you react it with hydrogen, and you get a margarine molecule, right? So the reaction, the way this works is that let's take a margarine. Let's take a vegetable molecule, which is going to look something like this. Now the vegetable molecule will have a double bond. Okay, so consider this a vegetable molecule. Okay, consider this a vegetable molecule which is now reacted with hydrogen, and you're gonna need two things. So you're gonna need a nickel catalyst. I don't know, every reaction love this nickel catalyst. And you're gonna need 150 degrees centigrade of temperature. Now, once you have these two things, I think you should already know what's gonna happen here. So this double bond, very unlucky double bond, is gonna get broken. Okay, this double bond is gonna get broken, and what's gonna happen? These two hydrogens are gonna attach itself in place of this. Okay, so oh, I made a mistake. I'm very good at making mistakes. Yeah, you should have one more carbon and hydrogen here, right? That now makes a whole lot of sense, because if not, then we're gonna attach the two hydrogens. Okay, so now these two hydrogens, the double bond breaks. So you've got this, and this, and you have all the hydrogens, and basically these two hydrogens get attached here. So now this becomes a margarine molecule, and this might seem familiar, and the reason it's familiar because this is the same process. This is an alkene molecule reacting with hydrogen and is making an alkane molecule. That's hydrogenation, right? This is what we studied. This is a hydrogenation of a vegetable oil. We call this hydrogenation of a vegetable oil. Right? But what is one more important thing here, this is basically just for knowledge, is that when this reaction happens, not all of the alkene molecules are converted into the margarine, or not all of the vegetable molecule is converted into a margarine molecule. And because of that, there is something which is also produced as trans fat. Now that trans fats are actually responsible with heart diseases. So even though hydrogenation takes place, let's say if we were converting 100 vegetable molecules into margarine molecules, not all of it are going to convert. Not all hydrogenation is going to take place. Some molecules remains, and some molecules come as a byproduct, and those molecules are then what are trans fats, which are formed due to the side reaction of the hydrocarbon chain with a catalyst, and that is related to heart diseases. Okay, so I just give you a little warning about eating margarine and all, right? So this is the end. This is where the alkene chapter ends. Okay, I hope that's clear.